Welcome to all here in the session of mathematics. In previous episode already we have been discussed some of the finite terms of arithmetic progression as well as geometric progression. In today's session we will discuss what is the arithmetic mean and geometric mean, and also what is the relation between arithmetic mean and geometric mean. Also we will do some problems related with arithmetic mean and geometric mean. So let us start with arithmetic mean first. Suppose the three quantities a, x, b are in AP. That means the middle number, that is x, is said to be arithmetic mean of other two, that is a and b. Now I will write here, you see, suppose a, x, b are in AP. That is, they are in arithmetic progression. Now you can write that implies x is the arithmetic mean, or symbolically denoted by am, of the two numbers a and b. Okay. Now to find the arithmetic mean x, what is the value of x? Now we should take the help of AP. That is, all of you know that T2 minus T1 is equal to T3 minus T2, which is nothing but the common difference D, isn't it? So here T1 is A, T2 is X, T3 is B. That means X minus A is equal to B minus X, or in other words, transferring minus X into this side, that is X plus X is equal to A plus B, or in other words, 2X is equal to A plus B. That implies x is equal to a plus b by 2, which is the single arithmetic mean. What is that? Single arithmetic mean. You can write here single am of the two numbers a and b. Okay. Now with the help of this relation, that is x is equal to a plus b by 2, you can find the arithmetic mean of the two numbers a and b. Suppose you have to ask to insert n arithmetic means in between the two numbers a and b. Then what will do? So a is here, and suppose the n arithmetic means are x1, x2, x3 xn, and b is here. So they are all are in AP. AP. Okay. Now here you see T1 is A, T2 is x1, T3 is x2, T4 is x3. Likewise, xn should be Tn plus 1, that is n plus 1th term is xn, and b is Tn plus 2. So n arithmetic mean in between the two number a and b means b is the, you can write b is the n plus 2th term of the AP. So with the help of the Tn is equal to a plus n minus 1 into d. All of you know this formula. So using this formula, here you can find a. Here a is first term is a. So a plus n. N is here n plus 2. N plus 2 minus 1 into d. This is nothing but the b minus a is equal to how much? N plus 1 into d. So d is equal to b minus a by n plus 1. What is d? D is the common difference of the AP. So first of all, you have to find what is d. D is equal to b minus a by n plus 1. N is the number of arithmetic mean inserted between the two numbers a and b. Okay, now you can find the first arithmetic means. What is that? That is x1. x1 is equal to only 1d, that is a plus d is equal to x1, and a plus 2d is equal to x2. Likewise, so x1 can be found by adding a plus d. D already we have found with the relation, that is b minus a by n plus 1, and x2 is equal to a plus 2d. x3 is equal to a plus 3d. Likewise xn is equal to a plus nd. Okay, these are the n arithmetic mean with the help of the relation d is equal to b minus a by n plus 1. You can find n arithmetic mean. Okay, so make it a note. Now we'll go to the some problems related with arithmetic mean. Now we'll take the first question. You read the question carefully. That is, he is asking, insert the 4 arithmetic mean in between the two numbers 3 and 18 so that the resulting sequence is in AP. So your supposition should be likewise. Let us start with solution. Let x1, x2, x3 and x4 are 4 am in between 3 and 18. So that implies 3, x1, x2, x3, x4 and 18 are in AP, isn't it? So the resulting sequence are in AP given. So from this one is T1, T2, T3, T4, T5, T6. So 6 term is 18. You can write T6 is equal to 18. That is nothing but the a plus 5d is equal to 18. What is a? A is equal to 3, or you can write 3 plus 5d is equal to 18, or 5d is equal to 18 minus 3, that is 15, and d is equal to 15 by 5, that is nothing but the 3. So x1 is equal to a plus d is equal to 3 plus 3, that one is 6, and x2 is equal to, that is a plus 2d. So 3 plus 2d means 2 into 3, that is 6, 9. x3 is equal to a plus 3d, that is 3 plus 9. 3 plus 9 is equal to 12, and x4 is equal to a plus 4d, that is 3 plus 12, which is equal to 15. So the 4 arithmetic means are, you can write hence, the 4 arithmetic means are 6, 9, 12, 15. So you can follow alternative process. Directly you can find the d, that is b minus a by n plus 1 is nothing but the 18 minus 3 by n plus 1, that is 4 plus 1. 18 minus 3 is 5, 15. 18 minus 3 is 15, 15 by 5, that is nothing but the 3. So you can write x1 is equal to a plus d, that is 3 plus 3 is equal to 6. x2 is equal to a plus 2d, that is 3 plus 6, 9, and x3 is equal to a plus 3d, that is 3 plus 3, 3 is a 9, 12, and x4 is equal to a plus 4d, that is nothing but the 3 plus 12, which is equal to 15. So any process you can follow. So make it a note. Now we'll take next question. Now take the second question. That is asking for what value of n, the an plus 1 plus bn plus 1 whole divided by an plus bn is the arithmetic mean of the two numbers a and b with a not equal to b. That means he is asking what is the value of n. For this one is the arithmetic mean of the two numbers a and b. So your supposition should be likewise. Let a n plus 1 plus b n plus 1 whole divided by a to by n plus b to by n is arithmetic mean of the two numbers a and b. So that implies we have a n plus 1 plus b n plus 1 divided by a to by n plus b to by n is equal to a plus b by 2. That is the single arithmetic means in between the two number. With the help of this relation, you can write a plus b by 2 is equal to this much. So cross multiplying 2 a to by n plus 1 plus 2 b to by n plus 1 is equal to a to by n into a plus a to by n into b plus b to by n into A plus b to n into b. So that is nothing but the 2 a to the n plus 1 plus 2 b to the n plus 1 is equal to a to the n plus 1 plus a to the n b, b to the n a plus b to the n plus 1. You see, transferring all these terms into LHS. 2 a to the n plus 1 minus a to the n plus 1. So we have left with a to the n plus 1. 2 b to the n plus 1 minus b to the n plus 1. So also we have left with b to the n plus 1 minus a to the n into b minus b to the n into a is equal to how much? 0. So now arranging a to the n plus 1 and minus a to the n b. Again these two terms also plus b to the n plus 1 minus b to the n into a is equal to 0. So taking common from these two, a to the n, then we have left with a minus b. Taking minus b to the n as common, we have left with a minus b is equal to 0. Now from these two, we will take a minus b as common, then we have left with a to the n minus b to the n is equal to 0. Since we have given a is not equal to b, that's why a minus b should not be equal to 0, but their multiplication is equal to 0. That means a to the n minus b to the n is equal to 0. From this, a to the n is equal to b to the n, or you can write a to the n by b to the n is equal to how much? 1, or you can write that is a by b whole to the n is equal to a by b whole to the 0. That means base will be same, then the exponent should be same, that is n is equal to 0. From this we conclude that for the value of n is equal to 0, this one n to the power n plus 1 plus b to the n plus 1 whole divided by a to the n plus b to the n is the arithmetic mean of the two numbers a and b. Okay, so make it a note. Now we'll take geometric mean. The number g is called geometric mean of the two numbers a and b if a, g, b are in geometric progression. That is, you can write likewise, the number g is called the GM or geometric mean of the numbers a and b if a, g, b are in GP. Okay, that means, so all of you know that T2 by T1 is equal to T3 by T2. Here T1 is A, T2 is G, T3 is B. That is G by A is equal to B by G, or in other words G square is equal to AB. So therefore geometric mean G is equal to root over of AB. So in this way you can find the single geometric mean in between the two numbers A and B. Now suppose you have to ask n geometric mean, that is x1, x2, x3 ... xn. Insert in between A and B. Now let the n geometric means, that is x1, x2, x3 up to xn are inserted in between the two numbers a and b. Now with the relation, that is the common ratio, you can find this one is the first term, this one is the second term, this one is the third term is x2. So xn will be tn plus 1 and b should be tn plus 2. So you can write b is equal to n plus 2th term of the GP if the common ratio is r here. Then we have b is equal to a r to the n minus 1, here n is n plus 2. So a is the first term, r is the common ratio, whole to by n minus 1, here n is n plus 2, n plus 2 minus 1. This is nothing but the a r to the power n plus 1. Now b by a is equal to r to power n plus 1, or in other words r is equal to b by a whole to power 1 by n plus 1. Now in this way, with this relation, first you have to find what is the value of r, then the first geometric mean, that is x1 is equal to ar, and x2 is equal to ar square, x3 is equal to ar cube, likewise xn is equal to ar to the n. So you can find the n geometric mean with the help of relation, that is r is equal to b by a whole to power 1 by n plus 1. What is a and b are two numbers, and n is the n geometric mean should be inserted in between the two numbers a and b. So make it a note. Now we'll take what is the relation between arithmetic mean and geometric mean of two positive real number, that is they are not equal to each other, a and b. So let a and g are the arithmetic means and geometric mean of the two unequal real positive number a and b respectively. Then we can find a minus g. So a is the arithmetic mean of the two number a and b, and g is the geometric mean of the two numbers a and b. So you can find a, that is a is equal to a plus b by 2 with the help of the formula single arithmetic mean, that is a plus b by 2, and g is equal to root over of ab. So we can find a minus g, that is nothing but the a plus b by 2 minus root over of ab. So taking LCM 2, we have a plus b minus 2 root over of ab, that is nothing but the root a square plus root b square minus 2 into root over a into root over b whole divided by 2, or in other words 1 by 2. Taking the outside, this one is root a minus root b whole square. So since a and b are positive real number and they are not equal to each other, that's why this should be greater than 0. If greater than 0, that means this one is greater than 0, that means nothing but the a minus g greater than 0. From this we will get a greater than g. This is the relation between arithmetic mean and geometric mean of two numbers. If two numbers are equal and b are equal, then a is equal to z if a is equal to b. That is if and only if. So arithmetic mean of any two unequal real positive numbers a and b should be greater than geometric mean of the two unequal real positive numbers a and b. So a greater than g. So make it a note. Now we'll take some problems related with all these geometric mean and arithmetic mean. Okay. Now we'll take the first question related with geometric mean. Read the question. Find the 5 geometric mean in between the number 576 and 9. So let us start the solution. So your supposition should be, let g1, g2, g3, g4 and g5 are the 5 geometric mean in between the numbers 576, which is equal to a, and 9, which is equal to b. Let r be the common ratio. Then we have a, g1, g2, g3, g4, g5 and b are in gp. Okay. Would you follow or not? So all these numbers are in GP. So from this we conclude that R can be found B by A whole to the power 1 by n plus 1. With this relation you can find B. We have BB is equal to 9 by 576 whole to the power 1 by n plus 1, that is 5 plus 1 by 6. So cancelling all these, so this one is 64. So 1 by 64 whole to power 1 by 6, this is nothing but the 1 by 2. So finding the value of R is equal to 1 by 2. Now we can find G1. G1 is equal to AR. A is equal to 576 into 1 by 2, that is 288. G2 is equal to AR square, that is 576 into 1 by 2 square, that is 1 by 4, that is nothing but the 144. Likewise you can find G3, that is AR which is nothing but the 576 into 1 by 2 cube, that is 8. 8 7 56, 8 2 72, that is G4 is equal to AR to power 4, that is 576 into 1 by 16, so is equal to 36. G5 is equal to AR to power 5, that is 576 into 1 by 32, that is 18. So likewise you can find all the 5 geometric mean in between the number 576 and 9. Okay, make it a note. Now we'll go to the next number. Now you take another interesting problem, that is given AM is the twice of GM of two numbers A and B with A is greater than B. You have to prove A is to B is equal to 2 plus root 3 by 2 minus root 3. Now what are the given condition? A and G. A is twice of G, that is AM is twice of GM. So let us start the solution. You should mention here, let A be the AM and G be the GM, that is geometric mean of the two numbers with A is greater than B. This one is given condition. Also given that what is that given? A is equal to twice of what is that? G. AM is twice of GM. Already we have found what is the AM between the two numbers A and B, that is nothing but the A plus B by 2. And what is the GM between the two numbers? That is root over of AB. So now A plus B by 2 root over of AB can be written as 2 or 2 by 1. Now by componendo and dividendo, what is that? A plus B plus 2 root over AB whole divided by A plus B minus 2 root over AB is equal to 2 plus 1 by 2 minus 1. What is that componendo dividendo? If A by B is equal to C by D, that implies A plus B by A minus B is equal to C plus D by C minus D. This is the componendo and dividendo. The basic knowledge from 10 class. By, you can write by componendo and dividendo. Now this is nothing but the root A square, that is a root A square plus root B square plus 2 root A into root B whole divided by root A square minus root B square plus root B square minus 2 root over A into root over B, that is 2 plus 1 is 3 by 1. See, this one is numerator, one is root A plus root B whole square by root A minus root B whole square. Now I will do here, that implies root A plus root B whole square by root A minus root B whole square is equal to how much? That is 3 by 1. Now taking square root both the sides, we'll get here root a plus root b by root a minus root b is equal to how much? That is root 3 by root over of 1 is 1, isn't it? Again by componendo and dividendo, what will get? Root a plus root b, this one is a, this one is b, so a by b is equal to c by d. When this one happened, then a plus b by a minus b is equal to c plus d by c minus d. This is the componendo and dividendo. Again you will apply here root a plus root b plus this one plus root a minus root b whole divided by root a plus root b minus this denominator, that is minus root a plus root b. Again this one is c d, so c plus d by c minus d, that is root 3 plus 1 by root 3 minus 1. So this is nothing but the root b cancel, root a cancel. So we have left with, now I am erasing this one. So this is nothing but a 2 root a by 2 root b. So here I can write by c and d. C and d means componendo and dividendo. This is nothing but the root 3 plus 1 by root 3 minus 1. Now 2 cancel, squaring both the sides, that is a by b is equal to root 3 plus 1 whole square, squaring both the sides, root 3 minus 1 whole square. Root 3 plus 1 whole square means 3 plus 1 plus 2 root 3 by 3 plus 1 minus 2 root 3. So 3 plus 1 4 plus 2 root 3 by 4 minus 2 root 3. So taking 2 as common from the numerator, that is 2 whole into 2 plus root 3 by 2 whole into 2 minus root 3. Now 2 cancel, so we have left with 2 plus root 3 by 2 minus root 3 is nothing but the a is to b is equal to 2 plus root 3 is 2 minus root 3, hence proved. Okay, now in this way you can prove. So you can write here by componendo and dividendo, by componendo and dividendo. So in this way you can do all this problem. So that's all for the today's session. In the next episode we will discuss harmonic progression and what is the relation between arithmetic mean, geometric mean and harmonic mean. So we will do all the problems related with AM, GM and HM. So until then, goodbye. Thank you.